Okay, everybody, today we are going to be multiplying and dividing rational expressions. So you just took your quiz on graphing rational functions, and now we're going to move on to some manipulation with them. So first things first, let's just a reminder of how we multiply fractions. Remember, we multiply fractions, we multiply across the numerator, across the denominator. We are not cross multiplying. That is only when we have an equal sign in between our fractions. So we multiply across, we get 10. We multiply across the denominator, we get 21. And since that cannot be reduced, that will be our final answer. Okay, when we're multiplying fractions, we could beforehand reduce top to bottom if possible. So we can divide both 8 and 10 by 2 first, and then multiply 9 times 4, 5 times 5, and those do not have any common factors besides 1, so we can leave it. And it says simplify your answer if possible, because that's what we'll be doing today with rational expressions. Now, just a reminder, and if we were in class, I would ask you, rather than dividing by a fraction, what can we do instead? And you'd probably say we can multiply by the reciprocal. Some of you know this as keep, change, flip, but rather than dividing by a fraction, we can indeed flip and multiply. And then we can reduce, or we can just multiply across the top, across the bottom, and then reduce at the end, divide everything by 2. Okay, so again, just a short review of multiplying fractions. When we multiply rational expressions, we are going to factor first, cancel common factors, and then we multiply across, because we don't want to keep in any common factors. If we can simplify from the beginning, make our life easier, let's do that. Okay, dividing rational expressions, we're going to focus on flipping, following the division sign. So we're going to talk about keep, change, flip. Okay, so remember, just a reminder, we talked about this in the last section we were graphing. We only cancel factors, not terms. So we can cancel when we're multiplying, but we cannot cancel the 4's here when we have the plus sign in the middle. Okay, these are separated by terms. We can only cancel terms when they are identical in numerator and denominator. So like here, if we had x plus 3 and x plus 3, since they're identical, we could cancel. But if they are not identical, we cannot cancel the x's there. It does not work that way, okay? Because they're connected by a plus or minus. They're separate terms. Okay, so let's jump into what we're doing. So simplify rational expressions. So first things first, let's just make sure we're always going to deal with anything in simplified form before we're multiplying or dividing. So I'm going to factor the numerator, and do in this case x minus 6, x plus 2. Factor the denominator into x minus 2, x plus 2. And since we have x plus 2 as a common factor in numerator and denominator, we can cancel it. That would reduce this to x minus 6 over x minus 2, and we leave it there. And then if there's something we have to multiply it by, another expression, we can do that or divide it, but at least it's in simplest form first to make our lives a little bit easier. Okay? Down here, we can cancel these, so we'll be left with 2 over x plus 3. Nothing you can do there, even if these are both 3's. Remember, we can't cancel because of terms in the denominator. X plus 4 over x plus 4x minus 4, difference of squares. What can we do here? We can cancel the x plus 4's. Just be careful, because a lot of you might say, oh, it's just x plus 4 that we're left with. We need that placeholder of a 1 on top, because remember, anything divided by itself is indeed 1. Down here, you're going to ask yourselves, are there any common factors? There are not. This is actually in simplest form. It cannot be factored any further. Nothing can be canceled. So that's okay. Don't cancel things just because you can. Make sure what you can actually cancel before you're doing it. And then here I will factor x minus 3x plus 1 over x minus 3 in this case, and x plus 2. So multiplies to negative 6, adds to negative 1, multiplies to negative 3, adds to negative 2. We can cancel the x minus 3's, so I'm left with x plus 1 over x plus 2. Okay, so just another practice. I know we did a lot of this in the last section, finding our wholes, factoring, but a refresher, make sure it's in simplest form. Okay, multiplying rational expressions. So let's get into it in this case. Now, rational expression is any expression divided by another. So these aren't necessarily polynomials divided by one another, but let's simplify where we can. So before we even multiply, let's simplify Remember when we have power over here, so same base, and dividing the powers, we would subtract in this case. So this would leave me with x squared in the numerator, and then y to the first in the denominator. Okay? If the bigger exponent is in the denominator, you can expect the variable to be left in the denominator, and vice versa. Then you can do the same thing here. The y will cancel in the denominator, we'll be left with y squared. So I'm just going to clean down what we have a little bit in this case. So we had 8x squared over 2y times 7x to the fourth, in this case y squared over 4. And we can actually cancel here, at least 8 over 2 can be simplified. If you want to do that in step 1, you can, and you can just make that 4. Just make sure it stays in the numerator. 8 over 2 is indeed 4. Okay? Now, what's nice is that we can combine all of this, or we can just cancel. It's up to you. So what I see is when I multiply across the numerator and denominator. So we can either cancel the 4's now, or you can wait because it'll be a numerator and denominator. But we would have 7 left in the numerator, x squared and x to the fourth, same base, add the exponent, so it'll be x to the sixth, and then we have y squared over y. And then just to simplify this down further, y squared over y to the first just becomes y. So at the end of the day, we'll get 7x to the sixth and y to the first power. So it's up to you if you truly want to multiply across first, but I would simplify what you can in the beginning to make your life a little bit easier. Next, first things first, remember, factor first and cancel what you can before you multiply and make it bigger. So here I can factor out a 3x. I'm left with, in this case, 1 minus x. Okay, if I factor out a 3x here and here, over, in the denominator, this factors into x plus 5 and x minus 1. Okay, so that's what I'm starting with there. And then I have times, this factors into factors of negative 20 and 4, so the x plus 5 and x minus 4. And then I'll have 3x in the denominator. Now, to make our lives easier, before you combine everything, remember we multiply across the top and across the bottom. So technically, this would just become all the numerator and all the denominator. So not only can I cancel the 3x's, but I can also cancel the x plus 5's. Okay, so let's simplify down what we have. 1 minus x minus 4 over x minus 1. And we are almost there. There's one little catch here. When we factor this, 1 minus x and x minus 1 are not the same. Okay, if you'll notice here, the 1 is positive, the x is negative. Here, the x is positive and the 1 is negative. So in class, I would ask you, what number can we factor out to make these two factor pairs identical? And a lot of you would tell me negative 1. So if we factor out a negative 1, that's going to change the sign, make the x positive and then 1 negative, so it becomes x minus 1. Okay, we still have the x minus 4 over x minus 1, and then we can cancel those x minus 1's. So I'm just left with negative 4 times negative 1, times x minus 4 is my final answer. So almost everything cancels down. And I'm fine if you leave it like that or distribute it back in, but I would just leave it factored down. Okay, remember, at any point in time, you are in control of this video. You can stop it, you can pause it, you can replay it. Okay? Okay. So a little review, at any point, remember, you might see difference of cubes, which you already, difference of squares, which we already saw. You could also see some in difference of cubes. So I put this up here as a little review for us. So for example, find the product. If you would like to, remember, everything is technically over 1. And then what I'll do here is I'll simplify and factor what I can. So x cubed minus 27 is difference of cubes. So remember, difference of cubes tells me that we'll have the first sign, and I'll leave this formula up here. We'll technically have cube root of x cubed is x. So a would be x, and b would technically be the cube root of 27, which is 3. So we would have x minus 3. And then the sign is the opposite, and the last sign is always positive. So we would have x squared plus, because it's the opposite sign, and then we're going to have a times b, so it'll be plus 3x, and then plus b squared, which is 9. and then we'll have times x squared plus 3x plus 9 over 1. If you want the over 1 there, you don't need to put it. I just like to put it so we know numerator and then denominator. So you'll see what's really nice happen here is that those factor pairs actually cancel completely. So all I'm left with is x plus 2 over, in the denominator, x minus 3 times 1, or just x minus 3. And as much as you want to, do not cancel the x's. They're connected by plus or minus. They are different terms, so you cannot cancel. That is what it simplifies to. Okay? So make sure, long story short, you are factoring completely and checking. I will be posting the key to these notes, so you'll see the key to the check-ins, so you can try them right now. You can pause your screen, and that way you can try these, and then check yourself with the notes that I posted. Okay? And then I'm going to move on. Remember, you can pause or stop at any point. Dividing rational expressions. So dividing and multiplying are essentially the same thing, just with one extra step with the dividing, which means we are going to keep, change, flip, just like our modified KFC symbol says here with our KCF. So we're going to keep the first fraction, change the sign from division to multiplication, and then we are going to flip the second fraction, aka multiply by the reciprocal. Okay, so instead of dividing, you hear me say it a lot, multiply by the reciprocal. So before I do anything, I'm going to start with that. Keep the first fraction, change the sign, flip the second fraction. Okay, I would not even factor until I do that to make sure that I'm not forgetting to keep, change, flip. Okay, because a lot of you might see the division, and then if you start reducing now, you might forget its division, and things may not cancel the way that you want them to, or reduce. So first things first, I'm going to simplify 7x. I'll factor out a 2. I'll be left with x minus 5. And then factors of 30, that adds negative 11. So immediately I'm going to negative 6 and negative 5. Multiply to positive 30, add to negative 11, and then I'll factor out an x. Okay, and here, if we didn't flip it, we would see these would still cancel, but our x minus 5s would not. So x minus 5 cancels here. So multiply across whatever's left. Left in the numerator was 7x over 2 and x in the denominator. Okay, so now you're going to ask yourself, can anything else cancel? And truth be told here, it actually can. We see that we have 7 times x and 2 times x. There are no terms here. They are one term, so I can actually cancel the x's. And this whole thing just simplifies to 7 halves. Leave it as a fraction, okay? If it were 7 plus x and 2 plus x, it would not work. But this is technically 7 times x and 2 times x, so we can cancel the x's down, okay? Example 2. So I'm going to start by immediately keeping, changing, and flipping. So keep the first fraction. Rather than dividing, I'm instead going to multiply, remember it's over 1, by the reciprocal. So 1 over 3x squared plus 5x. And then going to factor what I can. Okay, so see if there's a GCF. There is not. Over 4x squared times 1 over, and I'll put out an x here, 3x plus 5. Okay, now here's a little kind of hint. Now, we want things to cancel here. It doesn't mean that they always will, but I see that there's a 6 in front here, meaning that this can be 6x and x, or it can be 3x and 2x. And then I see a 3x plus 5 here. So I'm going to start trying, when I'm testing my factoring, my gets in check, with 3x and 2x, because I'm curious if 3x plus 5 is going to cancel. It won't always happen. Don't force things to cancel. Okay, check your factoring. But we want to multiply to 15. So let's try positive 5 and negative 3. So our inner terms add to 10x minus 9x. So 10x minus 9x does indeed give me 1x. So this factoring will work. And 3x plus 5 will cancel. But nothing else will really cancel. I'm left with 2x minus 3 in the numerator, times 1, over 4x squared times x, which is really 4x cubed, and you cannot cancel the x's there because of the terms in the numerator. So you are done. Okay, so just because it doesn't mean that, be careful that everything that's going to factor is going to factor and cancel, but if you see something like 3x plus 5, try that. See if that will work with your factoring. Okay? And example 3, I'm going to start by keep changing and flipping. So I'm going to keep the first numerator, and this is a complex fraction, a fraction, a fraction. So I'll keep the numerator. I will change the sign. Instead of division, I will change the sign to multiplication, and I will flip the entire denominator. So it'll be 2x squared z squared over 6y to the 4th. Let's cancel what we can. Okay, so immediately, and I don't, if you want to, before I simplified beforehand, you can combine them all and simplify after. That's really your preference. So 2 times 2 is 4. If you multiply across the top, you want to do it that way. That's up to you. But we would have same base, add the exponents. So it'll be x cubed, y, and then z to the 3rd power over 6 x cubed, y to the 4th, and then z squared. Okay, and now if you want to cancel here, you can, or you could do some simplifying there. It doesn't matter. So x cubed will actually cancel, which is beautiful. The y's, we have y to the 1st in the numerator, y to the 4th in the denominator. So we'll be left with y cubed in the denominator. And then z squared, this would really be z to the 1st power. And then 4 over 6, obviously, we can reduce to 2 over 3. So 2/3, the x is canceled. We'll have y cubed in the denominator. Remember, the larger exponent will go, if it's in the denominator, it will stay in the denominator. If the larger exponent is the numerator, the factor will stay in the numerator. So z cubed over z squared just gave me z to the 1st. And this is what this would simplify down to. Keep the first fraction, change the sign, division to multiplication, and flip the fraction, and then simplify. And you do not need the 1st there to do that. Okay, so little check-in. I will post the key to the check-in. Just remember, keep, change, flip. So you can pause this if you want to. You can pause this if you want to try these now. Okay, and then unpause when you're done and ready to check yourself. Review activity. So this was the last problem on there. So for our little review activity, this was seeing if you can figure it out. So I will actually post the key to both the review activities. So if you want to pause it now and try it, remember, keep, change, flip. So I would flip this as your little hint. And then as a practice, this is all multiplication. So multiply across the top, factor first. I will also be posting the key to this. Okay, so at this point, we are finished with the lesson. Make sure to go check the worked out notes for any of the problems that you wanted to try, and see Google Classroom, the substitute, or you can check there. So yeah, check Google Classroom with the substitute for your assignment that you have to do after this. I will see you all tomorrow. Have a great day, everybody. Good job.